Alright, section 2 of unit 2 covers angles and parallel lines. In our first video we're just going to go over some implications. In our next video we'll look at some of the examples. So let's get started here. If you know, so that is if somebody gave you or told you that this angle equals this angle, or this angle equals 30 degrees and that equals 30 degrees. So if you know, if it was given to you, if you know certain angle relationships, you get parallel lines. So when I say get, that means like it's implied. You've proven that those lines are parallel based on these angle relationships. And here's the ones that work. There's only 4 of them. If alternate interior angles are equal, then that implies that those lines are parallel. So in our figure here, we've got 3 lines. We've got U and L, and they're cut by a transversal T. So T is our red one that crosses across the other 2. It cuts the other 2. So that gives us 8 different angles. We've got these 4 where T crosses U, and these 4 where T crosses L. Okay, so we need to look at all of our angle relationships then. If the alternate interior angles are equal, then the lines are parallel. So in that case, that's telling us if 3 equals 6, 3 and 6 are alternate interior angles. If those are equal or congruent to each other, then line U is parallel to line L. So if I said that 3 is 130 degrees and line 6 is 130 degrees, well, then we'd say, okay, those are equal, those are congruent to each other, so line U has to be parallel to line L. Same thing. If instead of using 3 and 6, if we were going to use angle 4 and angle 5, if I said angle 4 was 50 degrees, 50 degrees, and 5 was 50 degrees, okay, again, those alternate interior angles are equal. That means for sure U is parallel to line L, okay, because nowhere on here does it have our parallel lines. It doesn't tell us that they're parallel. We can prove it if we know that the alternate interior angles are equal. Okay, looking at some other ones, going on to the next one. If alternate exterior angles are equal, then those would prove that the lines are parallel as well. Okay, which ones does that count as? Well, we can say 1 and 8. If angle 1 equals angle 8, then U has to be parallel to L. Okay, if again we weren't going to use 1 and 8, the other ones that would work for that is if angle 2, alternate exterior angles, angle 2 equals angle 7. Okay, again that means U has to be parallel to L, so long as those 2 are equal to each other. Okay, another one would be if our same side interior angles are supplementary, then the lines are parallel. So if I told you that angle 4 plus angle 6 equaled 180, then 4 and 6 are supplementary, and those are same side interior angles. That would prove that line U is parallel to line L. Okay, so the ones that work for this is if we have 4 and 6, like we said in green, or if we have 3 plus 5. If those equal 180, then again, U and L have to be parallel. Okay, so you don't have to take out a straight edge or a protractor or anything like that and show that this line continuing forever never touches this line continuing forever. We can just say or figure out that those lines will never touch as long as 3 plus 5, or angle 3 plus angle 5 equals 180 degrees, then we know that those lines will never touch. Okay, our last one that we know for sure is if the corresponding angles are equal, then the lines are parallel. So remember, corresponding angles, if we look at this box and we look at this box, okay, the corresponding angles would be like angle 1 and angle 5. If those are equal, then U and L have to be parallel. Same thing like angle 4 and angle 8. As long as those are equal, then U has to be parallel to line L. So all of the ones that work for that, again, 1 and 5, 2 and 6, 3 and 7, 4 and 8, those are all the corresponding angles. If those are equal to each other, then those lines have to be parallel. Okay, a word of warning though, just because you have vertical angles or linear pairs does not prove that lines are parallel. So if I told you, we'll do a vertical angle. If I said that angle 3 and angle 2 are congruent to each other, that only proves that they're a vertical angle. That doesn't tell us for sure that U and L are going to be parallel. So just because angle 2 equals angle 3, you can't say line U and line L are parallel. Okay, so vertical angles don't prove that they're parallel. Same thing, if I told you that angle 1 plus angle 2 equals 180 degrees, okay, that's the definition of a linear pair. Okay, just because we know that angle 1 plus angle 2 equals 180 degrees, that doesn't prove that U and L are parallel. We can't necessarily say that those for sure are parallel, okay, because these angles, like 7, 8, 6, 5, these ones might be totally different measurements than 1, 2, 3, and 4. Okay, we don't know for sure unless they tell you exactly which ones are congruent to which ones. If the only ones they tell you are 1 and 2 equal 180, then we can't say that U and L are parallel. Okay, so that's going to wrap it up for just our implications.